This is cubic functions, which can be found in grade 12 and grade 11 and advanced maths if you are, and any mathematics above grade 11. So this is cubic function. So today we're going to solve a question that was in paper 1, 2009, metric paper, and it's question number 12, where it says the graph of h of x is negative x cubed plus ax squared plus bx. Is shown that coordinate A and coordinate B are turning points of H, and they pass through the origin and further cuts the axis at C and Y. So we will definitely see that the turning points of B and the turning points of A. Now, and we can see that C, 0, and D are the roots of the graph. Now, the first question here is 12.1. Show that A equals to 3 over 4 and B is equals to 6. Let's begin. First of all, we are going to write the formula or the equation for question number 12. It says h of x is equals to negative x cubed plus ax squared plus bx. And we were given, so given the turning points, given the turning points are, you have A, which is a negative 1, negative 3.5, and a B, which is a 2 and a 10. So we know that from the definition of a turning point, we say h prime of x should give us a 0. So this is the definition of a turning point. So remember that we are going to get our A and our B from that formula. So let's differentiate h of x, which is negative x cubed plus ax squared plus bx. Now, h prime of x is a negative 3x squared plus 2ax plus a b. If you want to know how to differentiate, please check my videos from my previous videos. You will understand what I did. So let's use B. You can use A, you can use B, but I want B. Why? Because I have positive numbers, so I don't have a problem. So here, remember that at turning point, we are basically saying our h prime of x is definitely a 0. So this is the golden principle we are going to use. So we are going to say 0 is equals to negative 3, bracket, we are putting a 2 squared plus a 2, a of a 2 plus a b. So we say 0 is equals to, that's a 4 times that's a negative 12 plus a 4a plus a b. So in other words, we are saying 4a plus b is equals to 12. This is our equation number 1. We set it as equation number 1. So with equation number 1, remember we have got two unknowns. Therefore, but still you have your b as a 2 and a 10. And you have your h of x as negative x cubed plus ax squared plus bx. So we want to substitute directly inside for b. So we are saying 10 is equals to negative bracket a 2 cubed plus a of 2 square plus a b of a 2. So 10 is equals to negative 8 plus a 4a plus a 2b. So in other words, we take that is going to be 18 is equals to 4a plus a 2b. So we can divide by 2 both sides. We divide by 2 both sides. We get a 9 is equals to 2a plus b. So in other words, 2a plus b is equals to a 9. This is equation number 2. So with the two equations, we solve them simultaneously. So what we do is we take 4a plus b is equals to 12. This is equation number 1, as you know. And we take 2a plus b is equals to 9. That's equation number 2. Then, since they are linear equations, let's just subtract them. We get a 2a plus a 0 is equals to a... Yes, we are subtracting. So 12 minus 9 is actually a 3. So 2a is equals to 3. So your a is equals to 3 over 2. So this one is your a. We get the a as this part here. That is your a, which is 100% correct. Now use any of 1 or 2. And then you substitute. So I'll take the simple one. I take 2a plus b is equals to 9. Then I substitute my a. This was equation number 2 for those people to understand. Then I take 3 over 2 plus a b is equals to 9. So you will get a 3 plus b is equals to 9. So b is equals to 9 minus 3. B is equals to 6. So this one is our first answer, which we prove to be 100% correct. So you can see that we have answered 12.1. A is 3 over 2. B is equals to 6. Now let's go to 12.2. Calculate the average gradient between A and B. So we are going to calculate that. So we go. The average 12.2. Average gradient definition. We are going to say is equals to f of b minus f of a divided by the x of b minus the x of a. Now, if I look very careful, remember that my a was a minus 1 and a negative 3.5, and my b was a 2 and a 10. So basically what do we have? We have a 10 minus of minus 3.5 divided by a 2 minus of minus a 1. That is going to give us a 13.5 divided by 3. That will give us a 4.5. So that is the average gradient we get there. We go to 12.3. Determine the equation of a tangent h at x equals 2, negative 2. Now, 12.3. Remember that a tangent is a line that touches the curve. Y is equals to mx plus a c. Now, the first thing we do, we write our equation, which we heard. H of x is equals to negative x cubed plus, if I'm not mistaken, it was supposed to be a x squared plus bx. And we have got our a as a 3 over 2 and our b is a 6. A b is equals to 6. So h of x is equals to negative x cubed plus a 3 over 2 of what? X squared plus a 6x. So generally speaking, our h of x is equals to negative x cubed plus 3 over 2 x squared plus a 6x. This is our equation which we have there. Now, this is a curve. Remember, this is a cubic function. So it's a cubic function. So for us, if we differentiate, so if you differentiate a function which is cubic, you will normally get gradient, a function of gradient. So it's gradients, which is varying. So it is variable. The gradient is varying, is changing at every point. So that's why they said at x equals to negative 2. So first of all, let's find what happens at x equals to negative 2. So at x equals to negative 2, we are saying h of negative 2 is equals to a negative of 2 cubed plus 3 over 2 of 2 squared plus 6 of a 2. Negative 2, sorry. I have to put negative 2, negative 2, negative 2. So if you do that, you get a negative, positive, which is 8. Then here it cancels. Then you should get squared here. So it's going to be a plus a 6. Because it's going to be a 4. 4 times that divided by that, blah, blah, blah. Then you get also a negative a 12. So we get a 2. So it's actually at negative 2 and a 2. That is the coordinate. The tangent is going to pass through. So at h of x is equals to negative x cubed plus 3 over 2 x squared plus a 6x. Now we need to find gradient. Gradient is actually m, which is actually h prime of x at that point. So h prime of x is equals to negative 3 x squared plus a 3 over 2, drop down the 2, x plus a 6. So we are saying h prime of x is equal to negative 3 x squared plus a 3x plus a 6. So this is the gradient. So the gradient at x equals to negative 2, we are saying h prime of negative 2 is equal to our m, which is a negative 3 of a negative 2 square plus a 3 of negative 2 plus a 6. So we get positive here and a 4, negative 12 minus a 6 plus a 6. So we normally get a negative 12 is our gradient there. So we will put this gradient and say y is equals to negative 12 x plus a c. So we are at this point now. Remember, is passing at a negative 2 and a 2. Remember this coordinate we calculated. So we are going to put it inside. So a 2 is equals to negative 12 of a negative 2 plus a c. So 2 is 24 plus a c. So c is negative 22. So our equation becomes negative 12x minus a 22. This is the equation of a tangent. The equation of a tangent at x equals to negative 2. You have to say at that point because it's happening at that point. It's not happening everywhere. So question 12.4 says determine value for x, for the point of inflection, of h of x. So the point of inflection, first of all, h of x is equals to negative x cubed plus 3 over 2 x squared plus 6x. The point of inflection, it happens when you say h double prime of x is equals to 0. So let's differentiate that function twice. H prime of x, we get negative 3 x squared plus 3 x plus a 6. We differentiate it again, prime of x. We get negative 6x plus a 3. Now at that point, we are now saying our h double prime of x equals to 0. So remember this function. So we are the condition. Negative 6x plus 3 is a 0. So negative 6x is equals to negative 3. So x is at 3 over 6. X is equals to a half. That is our point of inflation. So that's okay. The last question is saying 12.5. Use the graph to determine the values of p for which the function of that, here's one real root. So we want to determine the 12.5. Here's one real root. Remember, they didn't say work, they said use the graph. So if you look at the graph, actually, you'll discover that we have something like this. It is passing through this point here, your y, or it's too short. Let's make it a little bit long, and your x here. Now, the point I want to emphasize is these are roots where I'm putting dots in the circle. These are roots. These are roots. Now, I'm going to put a color, red, to show you when the roots change. Now, if our graph is going to be like this, yeah, and it touches there, and it goes like that. So it means we have got 2, and these are twice, and this is 1. You see? So we have got 2, 1, here x is identical to another number. If it's minus 2, x is minus 2 twice. And this one, x equals to 3. These are the roots. But now when it goes a little bit up here, it will definitely have one real root. So where is our story? Our story is you have to look at where this graph has this value here. Negative 3.5. And the top part was a 10. There we go. 10. So we are going to shift this graph up. And if you look very careful, the equation we were given is negative x cubed plus 3 over 2 x squared plus 6x plus a p is equals to 0. So if you look at this one here, I can write it as h of x plus a p is equals to 0. I can write it as h of x equals to negative p. Like this. This is the easiest way to understand. Meaning that this one here is a line. So this is a line. So we have this line here. So this line is actually x equals to negative 3.5. Negative 3.5. And this one is actually our p is equals to negative p actually is equals to 10, right? So basically what we are saying is we are saying p negative p is equals to. Now, if you don't want to be confused, you write h of x is equals to, let's say, n. Let's make it n. So that you can say this is your n equals to negative 3.5. And this is n is equals to 10. So in other words, we are going to push the graph up. So n is greater than, is greater than minus 3.5, where, like that, yes. So in other words, if I put negative p is less than. Okay, let me try and explain it in another way. Okay, let me just have a video for that part, then I will explain everything, how you shift the graph. So check my short. I will make a short video for this explanation in the shorts. Check in my channel and check for the shorts where I say explanation of the cubic function. I will say 12.5 explanation cubic function. Thank you. Please subscribe and like my videos.